The Italian landscape is a masterpiece, rolling hills, ancient towns, and breathtaking mountains. But beneath this idyllic beauty, the ground is alive. It's moving, stretching, and breaking. This isn't the gentle rhythm of the earth, it's a slow-motion geological battle. And right in the heart of Italy, along the spine of the Apennine Mountains, this battle is creating the conditions for a potential catastrophe. For the thousands living in the valleys and on the slopes, the very mountains that frame their lives are becoming dangerously unstable. A massive flank collapse is a risk that scientists are taking seriously, a threat fueled by powerful forces building day by day. This isn't just speculation, it's a warning written in the very rocks of the mountains themselves, a warning scientists are desperately trying to understand before it's too late. To get a handle on the threat, we first have to understand the Apennines. Stretching over 1,000 kilometers down the Italian peninsula, these mountains are literally the country's backbone. They're home to medieval villages, critical infrastructure, and vibrant ecosystems. But geologically, they're young and restless. They aren't a single, solid block of rock, but a complex, fractured system of faults and folds, pushed and pulled by some of the most powerful forces on our planet. The core of the problem is that these mountains are fighting a war against themselves. On one side, you have immense compression. East of Italy, the African tectonic plate is continuously diving beneath the Eurasian plate. Picture a colossal, slow-motion car crash that's been happening for millions of years. This collision crumpled the crust, forcing the rocks upward to create the Apennine Range in the first place. This is what's known as a compressional regime, and it creates a landscape where huge slabs of rock are pushed up and over each other. But that's only half the story. At the same time, on the western side of the mountains, the crust is being pulled apart. The Tyrrhenian Basin, under the sea to the west, is opening up and stretching the land. This creates an extensional regime where the ground literally drops along faults, creating deep valleys and basins. Imagine a piece of clay being squeezed from one side and stretched from the other. It's going to tear, fracture, and become incredibly weak. This is what's happening to the spine of Italy. It's being simultaneously compressed and extended. A geological paradox that makes the entire region intensely unstable. Every earthquake, every tremor, is just a reminder of this ongoing battle. This tectonic tug-of-war isn't just a textbook concept, it has devastating, real-world consequences. The constant stress creates a dense network of faults, some of them 10 to 20 kilometers long. These aren't ancient, inactive scars in the rock, they're active wounds. Movement along these faults is sporadic, but it's relentless, averaging about 3 millimeters of separation per year. That might not sound like much, but this stress doesn't release gently. It builds for decades or centuries until the rock can no longer take the strain. Then, it snaps. That's exactly what happened during the 2016 Central Apennines earthquake sequence. A series of powerful quakes, including a magnitude 6.2 and a 6.5, tore through the region, killing nearly 300 people and reducing historic towns like Amatrice to rubble. Those earthquakes were the violent release of extensional stress, the ground literally pulling apart. They didn't just shake the ground, they physically changed the landscape. GPS data showed that the earthquake sequence caused the land in the hardest-hit areas to widen by several centimeters. But here's the most alarming part, what seismologists call the domino process. When one fault ruptures, it doesn't relieve stress on the whole system. Instead, it transfers that stress to its neighbors, like a chain reaction. One quake can weaken a sister fault, bringing it closer to its own breaking point. This is why the 2016 event wasn't a single quake but a sequence that unfolded over months. This cascading failure can continue for hundreds of kilometers, meaning the entire mountain chain remains on high alert. Each earthquake acts as another tick of the geological clock, further fracturing the rock, creating new weaknesses, and preparing the slopes for the ultimate failure, a large-scale flank collapse. Tectonic forces may load the gun, but it's often water that pulls the trigger. The fractured, broken rock of the Apennines is like a shattered piece of safety glass, full of cracks and ready to crumble. Now, add water. Climate change is leading to more extreme weather events, and when intense or prolonged rainfall hits, it seeps deep into these fractures. This does two critical things. First, it adds immense weight. A cubic meter of water weighs a metric ton, and we're talking about billions of cubic meters soaking into a mountainside. Second, and more importantly, it increases something called pore water pressure. Imagine the tiny spaces, or pores, between grains of rock. Normally, the friction between these grains helps hold the slope together, but when these pores fill with water, the pressure pushes the grains apart, reducing that friction. The slope loses its internal strength. Think of a sandcastle. When it's damp, it's strong. But if you pour a bucket of water on it, it turns to mush and flows away. The same principle applies to a mountain, just on a terrifyingly larger scale. This is a well-documented cause of landslides across the Apennines. But there's an even more subtle process at work. The region's geology includes layers of soluble rock, like limestone. As groundwater, channeled by the fault networks, circulates through the mountain, it can slowly dissolve these rocks, like sugar in tea. Over thousands of years, this can create vast underground voids and cave systems. In some areas, this has led to the formation of sinkholes which can collapse suddenly. This means that parts of the mountain aren't just fractured on the surface, they're being hollowed out from within, making them even more susceptible to a catastrophic collapse. The mountain is being weakened from the inside out, creating a ticking time bomb powered by rain. So what does a flank collapse actually look like? It's not a slow, creeping landslide, it's an avalanche of rock, soil, and debris moving at hundreds of kilometers per hour. A literal mountain in motion. To understand the catastrophic potential, we don't need to look far. We only need to look at Italy's own tragic history, the Vajont Dam disaster of 1963. The Vajont Dam, one of the tallest in the world at the time, was built in a valley in the Dolomite Mountains. Geologists had warned that the mountain flanking the reservoir, Monte Toc, was unstable. Its name, Toc, even meant rotten or soggy in the local dialect. The geological structure was frighteningly similar to parts of the Apennines, layers of limestone mixed with weak clay, all tilted precariously towards the valley. On October 9, 1963, after days of heavy rain, their worst fears were realized. A 2-kilometer-long section of the mountain, a mass of 260 million cubic meters of rock, collapsed into the reservoir in under a minute. The collapse was so fast and massive that it created a megatsunami 250 meters high that surged over the top of the dam. The wall of water scoured the valley below, completely obliterating the town of Longarone and several other villages. Almost 2,000 people were killed in an instant. The Vajont disaster is the ultimate case study. It had all the same ingredients: a geologically weak and fractured mountain, steep slopes, and the triggering effect of increased water pressure. Now, imagine a similar collapse today in the Apennines. It wouldn't be into a reservoir, but directly onto the towns and infrastructure nestled in the valleys. Communities could be buried in seconds. The 2016 earthquakes already caused landslides that blocked access to towns. A true flank collapse would be an order of magnitude more devastating, an event from which there would be no escape and no recovery. The science paints a clear picture. The Apennine Mountains are a dynamic, dangerous environment. The collision of tectonic plates has built a fractured, unstable spine. The relentless pulling of the crust creates the earthquakes that further weaken the rock. And more extreme rainfall provides a final potential push, lubricating faults and hollowing out the mountain's core. We see the warning signs in the seismic data, in the small-scale landslides, and in the very geology of the land itself. The historic villages and scenic valleys exist under a constant growing threat. We know from disasters like Vajont what is possible. The major question scientists are working to answer is not a collapse could happen, but the risk is greatest. For the communities living in the shadow of the Apennines, understanding this geological threat is the first critical step towards preparing for the future. What would you do if you knew the mountain next to you was on the brink? If you found this video insightful, please subscribe for more deep dives into the forces that shape our world. Share this to raise awareness about this critical issue. And let us know in the comments, what do you think can be done to prepare for a colossal natural threat like this?